Welcome back, everyone. Sì, sembra un po' alto. No, sembra un po' alto più che altro. Welcome, everyone. We have the afternoon session starting now. We have Luca Deri presenting about modern network traffic monitoring. Enjoy.
Thank you. Hi, good afternoon. The idea is to talk a little bit about network traffic monitoring in 2016. At least this is my idea. And we believe that the keywords here are three, basically: visibility, security, and awareness. Visibility, it is necessary because it is important to see what is happening in our network. But visibility without security, so try to identify those activities that somehow are suspicious. It's also important, but these two things, are important as the key ingredients for awareness. Awareness means to perceive that our network is safe, is running well, just because of that. Because visibility gives you just an overview of what is happening. Instead, you need to be aware that certain things are happening on your network, and you are happy that they happen, in the sense that you have set up your policies in a way that they have been configured properly for that. I want to show you a little bit how to do that with mostly open source software traffic components. Most of the things that I'm gonna show you here today are open source and available on GitHub. Others are partially open source. Some key ingredients are kept secret. And we believe that one of the main problems with network monitoring is that over the years it has been perceived as a nice to have activity. So namely, you can survive without it. If you have it, is better, but it's not compulsory. And this is a problem, mostly because vendors for years have not invested much money on that. And you see, we are mostly spending time counting bytes and packets. That is not enough. For instance, in modern networks, those are not so important. Latency, for instance, is a metric that is much more relevant than that. So therefore, the fact that most network equipment are not able to provide you much is not a good argument anymore. This is the topic that I want to describe today. So let's move at three layers: packets, flows, and activities. For years, and even today, before we talk about packets, packets is the most raw information element you have in the network. Packets never lie, okay? It's a true statement, of course, but it's very raw. So it means that you have a lot of packets, many packets in your network. You cannot analyze them at all. So over the years, we tried to move to a higher layer, flows. Flows is a way to compress this information in a way so that all packets belonging to the same flow, so with the same protocol, the same IP, source and destination, the same port, source and destination, are kind of together. This way, okay, we have moved to an upper layer. But what we really want is to move to the third layer, to the activities. I don't want to know too much about the internals of my network. I don't want to know about the MPLS labels, the MAC address, or the IP. I just want to know activities. I'm good or not. The fact that my PC is sending an email 4 a.m., is it normal or not? The fact that I will be receiving this email is probably good, but the fact that it is sending, and it's a workstation, it is probably not a good thing. So therefore, we have to move at these layers. But here, most of the people in this room are XPs. So you don't care about that. So you have different metrics in mind. So we must be able, in terms of network monitoring, to provide tools and data to people who need, certain type of information. Not all users of the network are alike, because depending on who you are, it depends also the type of information you're looking for. For years, we try to overcome, limitations and issues mostly created by vendors. So you see that there are, companies, that Cisco, Juniper, Arista, or whoever, that have created standards and some sort of dialect of those standards. And many people have been locked in by those guys, okay? And this was a good argument years ago for saying, okay, I cannot do more than bytes and packets just because it is not feasible on my network. And over the years, people have decided to move from this paradigm, very network-oriented, to data-oriented paradigm. So in essence, you want to see the data. You don't care where the data is coming from. And I believe that one of the first companies that managed to do that was Splunk years ago, when they said, okay, give me all your data. I don't care. I will put the data somewhere in a place that you can access and merge together. So you are no longer locked to vendors. And then because of the big data movement, so people that like to store everything everywhere, similar to Gmail but for networks, okay, we moved people towards more web-oriented representations like JSON, for instance. JSON was not designed for network, but it's now everywhere. So if you have a big data system, you must pick JSON. And those things, okay, together with the fact that we need to compress information because we are producing too much information, but compress does not mean gzip. It means that we have to reduce this information to those activities that are relevant for our network. If there is a problem, it's relevant. If somebody is transferring a file and is doing that nicely, it's not a problem. So we have to try to reduce the information to the things that we care about. These two things, okay, made people perceive the fact that even though you have a big data system, you have too much data, so you have to compress it. You have to discard information that is not too relevant for you. So how can we decide what information is relevant or not? Over the past 3-4 years, people started to talk about augmented flows. So I mean, to put something extra in the flow that gives you extra information. A typical example is for HTTP, the URL, the system you're accessing, for SSL, the server name, for DNS, the query that you're issuing, and the response code. This is the typical information that you need for that. So you don't just want to know how many bytes my PC has moved, but you also want to know the top destination, and likely to discard those destinations that are not relevant for you because you don't care about advertisement and all the rest. You just care about these things. But how do we do that if the speed is increasing? Like I said before, one of the barriers was the creation of substandards by vendors. Okay, it is not possible today, even if you go in the market and buy two different and very popular equipment, like the one from Barracuda Network or Cisco ASA, let them speak and operate together, because the way they emit information, beside basic IP and port and bytes, is totally incompatible. So you cannot really merge this type of information. But at the same time, I believe that there are movements that are successful, okay, that are pushing people towards some sort of standardization. So I mean, S-Flow and NetFlow, with all the limitations, all the problems they can have promoted this type of unification. So you can have more visibility today than what you had 5 years ago, for instance. In addition to that, you must understand this information and picture it on a graphical user interface with a fast rendering engine, because people today are used to being real time. So when you send a tweet, you immediately receive the tweet. Your friends are receiving that. And the fact that you have values that are an average value, like in the Cisco NetFlow, you have to wait 5 minutes or 2 minutes before a certain flow is emitted. So the latency is becoming a problem. People are used to real time, and people want to see real time. And like I've said before, when we are generating flow information, the 5-tuple information is something you take for granted. Like the Bluetooth on a mobile phone. You don't ask anymore if a certain telephone has Wi-Fi or Bluetooth included. It must have, period. There is no discussion about that. So we are moving now towards more metrics that are more application-oriented, like the quality of experience, for instance, the HTTP service time, that is very important for network providers, or for instance, latency, retransmission, these type of things that make people perceive that there is a problem on the network. That I mean, like I said before, maybe are not too relevant for carriers, but are important for users. So you need to understand this type of things. And this one, combined performance with and security are becoming more and more important. So you cannot simply still have, the same picture you have seen 10 years ago with RRD-like, okay, bytes and packets. They are good, but we need more than that. So let's start from the end. Affordable. Until a technology is affordable, it's basically useless, because very few people can buy that, okay, and becoming a niche technology, Whereas here, we need to have something that is more, let's say, open to everybody. Because if we have this technology open to everybody, then it's becoming pervasive. If it's pervasive, everybody's going to adopt it. If everybody has that, then we are richer than before. So a typical example, okay, for compressing the information is to move from packets to flows. And this is happening, in the network device, very unlikely to happen because you know that, most routers are limited in CPU capabilities. Also, many network administrators don't feel brave enough to enable those features in the router, even though they are present. So many times, we try to put the spam ports and external tools that are generating flows. But what is high speed today? We have heard this morning talking about 10, 20, 100 gigabit and above. So what I can say is that medium business today has 10 gigabit, at least the link that is connecting the switches. And an ISP in a large business has 40, is moving towards 100. We can discuss here that there are new speed coming, like 25 and 50, but I mean, the idea is that the 10G is now kind of commodity, it's for a standard business, and we're moving up. So much more data. All traffic must be monitored, not just the core traffic. So we cannot say, okay, I will put at the center of my network the router and so on. This morning we have heard that there are many encapsulations and that the traffic is very dynamic. And it is much cheaper and effective to monitor the network at the edge in addition to the center or just at the edge. So it's becoming to do it at the edge. So talking about money, so a good affordable ballpark, from my point of view for network monitoring, when I mean monitoring, I mean flow-based monitoring enriched with extra metrics, should be something like that, where most of the money is going to hardware. So just to talk about high-end 100 gigabit, so most of the money here is the server cost and the cost of the card, but these things are changing. So for 2 times 10, so I mean you take a 10 gigabit link, you tap it, and you take the traffic out, and you generate flows out of it. Line rate, no matter what, should be about 2,500 euro. For 100G, okay, today it's a very hot technology because it's becoming pervasive. Okay, it takes a little bit of time. It's not yet here today in every place. But just to have an idea, look at this card. This card has 2 times 100. Is based on a controller called Red Rock Canyon from Intel. This card costs $1,500 US. 2 ports, no optics. The optics are more expensive than the card itself. And because it has a switch inside, you can use this card for monitoring, but you can use this card for offloading activities that are typically done in the CPU. So for instance, you can create a firewall with this. This card is running at 1025, 14100. So you can offload to this card things that are usually doing in CPU, but at those speeds are not feasible. So prices are dropping. However, because we have a lot of traffic, especially at 100 gigabit, we need to split the traffic across CPUs. So if you have 2 CPU, so 2 NUMA node machine, you have the problem of respecting traffic coherency between the 2 direction of your tap. So if you have one direction with one port, the other direction with other port. So manufacturers are creating creative solutions. This is an example from Napatech. But in general, they are trying to overcome this type of problems. They are trying to balance the traffic in hardware so that the software application can really do that easily. And of course, if you have a 100 gigabit network, or if you're planning to have a 100 gigabit network, you don't want to throw in the trash bin everything you have at 10G. So there are other solutions for doing that. There are solutions like this one. This is the Dell Z9100 that allows you to merge this type of technology, so the different type of network port and speed into a single chassis. And with this chassis, this is just an example, and it's not this is not an ad. You can program it remotely and configure it remotely through technologies like OpenFlow. So in essence, you can monitor several links of your network, merge them together, and split the traffic. The difference between this approach and a card-based approach is that this one is static, so you must know in advance how to balance the traffic across all the available ports. So you must know the IP range or the IP ports or the services. Whereas if you have a hardware device like the Intel I've shown you before, that by the way is much cheaper than this, you have a dynamic balancing across all the CPU cores. So in essence, what I wanted to say is that we are moving towards higher speeds. It is not a problem. Don't worry, you don't have to put everything in the trash bin. If you buy a card like the one I showed you before, or this card, or this device, you can preserve the existing investment simply buying the right type of optics, because you can use those cards at a various speed. It is possible to monitor, so it's a positive thing. And like I've said before, it is possible on those network adapters or even in OpenFlow to offload activities that you are typically delegating to routers or to more security-oriented appliances for dropping traffic. And the whole statement is that today it is possible with a standard server, so nothing magic, so Intel-based server and those type of cards for below 25,000 euro to monitor a 100 gigabit link, 2 times 100, so 200 in total. So for 10 gigabit, we are talking about 1/10 of it. So it is really commodity. But people sometimes are not happy of flows. They believe that a flow is good, but they need something more precise, more accurate. So one of the things that is happening these days is that something that I call flows for everything, pick up for something. What does that mean? It means that I want to keep a track of all the activities happening on my network somewhere on a big data system, on a log file, in a place that I can retrieve it at some point if I need. But because people are used to have packets to analyze with their favorite tools, it is also necessary to implement something more precise, pickup based. And because if I want to save traffic on disk, as you can see, is becoming a big problem, I need to reduce the amount of packets I want to save on disk to only those activities that are relevant. For instance, a non-relevant activities for sure is to save on disk Netflix traffic. I have nothing against Netflix, by the way. But it's not information that is meaningful for you. You want to save information only about your stuff, okay? But packet filtering on this type of things can happen only at layer 7, or at least with sophisticated filtering capabilities, because filtering on port 80 does not help anymore. So it is important also to glue together flows with packets. So in case you have a flow that is somehow relevant for you, and you want to save packets, you can extract the packets for this type of things. So a typical deployment is the following. You have several network adapters or several ports. You have one application that can generate flows out of everything, and only for selected traffic that is meaningful, that is probably an IDS that is telling me this traffic is more relevant than other, you want that this traffic is sent to disk. So you can save to disk non-encrypted traffic for later analysis. But when you're moving to 40 or to 100, okay, it's becoming complicated also to start Wireshark. So if you have a problem with your server, you're tapping your main link, you cannot simply start Wireshark, capture everything, and then filter for IP. So we need something more than that. So in order to do that, we cannot rely on typical solutions such as those that are provided by computers. So by you say, give me TCP, import something of this host, and good. So we need something more than that. And the positive thing is that one of the things we have developed, that again is on GitHub, is the ability to offload to hardware those filters. Because one of the problems is that modern hardware is very powerful, but unfortunately operating systems are not exploiting it all the time. So a typical example is filtering. The typical thing that you do on a costly router are also possible to do on a cheap card, simply because the chipset is the same. It's just the port that is different. So with this type of technology, it's possible to filter at 100 gigabit line rate or 4010. You can scale down as you wish. And that if you want to troubleshoot to two machines that are speaking together, you can do that even on a busy 100 gigabit link. And like I've said before, flows must be richer in information. It is possible to do it today because it's possible to create this type of information that is becoming more important than bytes and packets. Believe me, application latency or service latency, so the time it takes to serve a user request, is becoming much more important by the number of bytes and packets that a certain host is doing. So this type of metadata is important because it can be used to detect and pinpoint problems. So if you have a security problem, you cannot simply filter for a certain port, but you have to filter out information based on metrics that are relevant and others. So if you have a certain DNS request that is failing, or if you have a certain HTTP request that is failing, you must go and filter based on the request, on the URL, or on the host. So metadata is important. And just to wrap up together, we have created many software through the years at NTOP that you can see can be merged together. So we have on the left PF that it's an open source library that allows you to capture traffic at very high speed, even at 100 gigabit. And we have created this probe called mprobe Cento that is able to analyze at 100 gigabit line rate 2 times 100, so the 2 direction, merging traffic, and generate flows out of everything. So we can generate flows, or we can send those flows in JSON format to a big data system. And of course, you can optionally save traffic to disk, or you can balance out specific traffic to IDSs or IPSs. And this is important because you cannot simply use one tool for everything, but you need to merge several technologies. So for instance, you can use an IDS to inject back some feedback to the system so that you can save to disk specific traffic just because the IDS has decided that it was more relevant than other traffic. And of course, we have the console called NTOP that allows you to visualize these things in real time, because like I've said, it is important. But talking about analytics, one of the things that the people are demanding today, they want a few things. First of all, they want to have something in real time, unaggregated for some time. So they want to know exactly what has happened. And they want to merge information from flows and routing so that you have a complete picture of what is happening on your network and be open and for other tools to use the data. So a typical set of expectations made by users is the following. At least 3 months of accessible raw data, so no aggregated. So if you have a problem today, you can go back to last week and see what has happened. You want to have a very fast, so less than 2 seconds, responsive user interface so that whenever you click, regardless of the number of flows, you can have a very fast data visualization. And you want to have interactive BGP path visualization because I believe this is more important for all of you. And this has to be done instantaneously, at least for most of the things on the screen, okay? So this is a typical example of such a solution that allows you to integrate things that are coming from network performance, visibility required by users at different levels in a central solution. So this type of solutions are possible with open source or combining open source with non-open source things. And then the last thing that we are doing, just to mention that we'll be releasing this month, it's a software-based DDoS protection tool. We started this project because we wanted to protect our own monitoring tools, because sometimes people were under attack and our tools were on nuts. But over the years, we have understood that this was a problem. There are no such solutions for the edge. For the center, okay, if you can afford to buy them, you're good. But for the edge, it is not possible. So this is one of the things that we are doing to combine also security with this type of monitoring, because it's important to combine all of them. So just to conclude, what I wanted to say is that there are on the market solutions, open source or not, that some of them have been mentioned today, that allow you to go beyond bytes and packets. It's not a good excuse anymore to say, I just want to have, simple graph that tell me how much is the load on my network or on my link. These metrics are still relevant, but we can now produce much more than that. And also what I've shown you is that using software-based tools on modern hardware and those recent innovation in network adapters, it is also possible to monitor 40 and 100. So we cannot simply limit ourselves to lower speed 1G or 10G, okay? And like I said, most of these tools are presented today are available on GitHub, but some of them are not, but they're free for education and research. Thank you very much.
Do you have any questions? Okay. We can move forward with PMA CCT and streaming telemetry, our own power.